Welcome to this session on the Oracle NoSQL Database Cloud Service. My name is Dave Rubin, and I am the Director of Development for the NoSQL Database, as well as the Cloud Service. We're going to take you through a little bit of background on why people are using NoSQL databases today, what kind of use cases we predominantly see out there. Then we'll take you through the Oracle NoSQL Database Cloud Service and why we believe it's the world's most flexible NoSQL database out there on the market today. So what we see developing over the last several years is that developing modern apps, and these are apps that run on a multitude of devices as well as, of course, in the browser, either on the desktop or the device. But they all really require a very similar development pattern, and that is they really need a diverse set of tools on the back end. No matter what kind of application you're developing, the bottom line is that you need a rich set of tools in the toolbox on the back end, whether that's a very scalable, robust, reliable IaaS platform, whether it's private data networks on the back end or relational database cloud services, or in our case, NoSQL, or for example, Kafka as a service for messaging. The bottom line is that you really need a number of different technologies these days to develop really rich applications. And some of the use cases that we predominantly see out there are listed here. The first one being personalization. So as you think about some of the apps that you interact with today, or even publications that you like to read with contextualized content that you like to visit all the time, one of the key things you'll notice is that these sites or these services, when they render pages, they're typically rendering those pages customized to you or to the individual based on your browsing behavior or products you've shown interest in, products that you've ordered in the past. And typically the way that these apps are personalizing the user experience is they really need to read at runtime, typically tens to hundreds of fragments of little pieces of data to actually render these applications. So really what you need to do is to read these little fragments from the database at predictable low latency. Even as you're scaling out your user base, you want this notion of predictable latency for reading small little data fragments to really render the page at constant rendering time between 1 and 2 seconds, and actually customize that to the individual. So we see NoSQL with its ability to offer predictable latency as well as scaling out horizontally as the typical platform for this UI personalization. Another use case that we typically see is to store simple metadata. So there are always these times when you're developing certain applications where you just have the need to store a simple key value pair. Maybe, for example, you're developing a platform for all of your microservices. You may need to scale these things out at some point, or you may have hundreds of them and you may be scaling them out to maybe a few hundred or even thousands of microservices on the back end. The bottom line is that you just need a reliable, scalable store with predictable access time to just store simple metadata. Again, maybe some key value pairs for application configuration, for example. Another common use case we see is with IoT, Internet of Things. This is the notion of being able to ingest at a very high velocity, sometimes millions of events per second that are being generated by machines. So you need to be able to scale that out horizontally. And then one of the key pieces for the IoT use case is the ability to just auto expire that data out on some cycle of your choosing. So for example, in advertising, some of those events will expire 30 days, 60 days. Of course, it really depends on the application or the space itself in terms of the expiry. But the bottom line is that NoSQL is really, really good at just setting up auto expiry and then expiring that data with zero effect to the ongoing operations in the data store. And then finally, the last use case we'll talk about of the many use cases we see for NoSQL is this notion of allowing consumer scale access to back office data. So no longer is it the case where you have a bunch of data in the back office for orders and inventory, where the only folks that would get access to that data are the folks in the back office. We now see consumer scale access to this data. Everybody is used to being able to go check the status of an order, check the status of inventory, track where that order is potentially in its manufacturing or delivery cycle. And then what we see is that to be able to offload that query from the operational data store, people are actually taking this data and serving those queries from the NoSQL database so that they don't affect the operational capability of the backend system. So as far as Oracle NoSQL Database goes, we have spent a lot of time really focusing on designing this product and the cloud service specifically for the development experience. And we've really focused on three areas here. We really wanted to simplify the development experience. So of course, the predictable low latency so that developers don't have to worry about sizing the application and coding for trying to figure out how to get predictable latencies. It just is taken care of on the back end by the system for you. The fact that all of the language drivers are open source. They all live in GitHub. You can find all of the source code there. They're lightweight. They're native to the language itself. We offer drivers in all of the predominantly popular languages, Node.js on the JavaScript side, Python, Golang, Java, C#, with other languages coming out as well. But the bottom line is all of these drivers live in their respective repositories where you as a developer expect those to live. So for example, Python, you can find the driver on PyPy, just search for Borneo or Oracle NoSQL, NPM for Node.js, Maven Central for Java, and then of course for C#, the NuGet repository. The second sort of major tenet that we focused on is really to try to give folks the kind of development experience where once you've actually used our APIs and all of the sort of convenience APIs and tooling that we give to the developer, that folks will walk away really happy that they've actually developed an application on the platform. So the bottom line here is you want to be able to delight not only your customers by delivering really nice, rich, personalized, and snappy application experiences, but you really want developers to walk away after they've written some code against that platform actually happy that they did so. And on the tooling side, one of the things that we've done, which we think is really great for developers, is we offer developer plugins for all of the major IDEs out there. So for IntelliJ, we have a plugin that you can find on the JetBrains repository. For Visual Studio Code, we have a plugin coming out in a few weeks that will be uploaded to the Visual Studio Marketplace. And finally, for Eclipse, there's a plugin in the Eclipse developer marketplace. Okay, so finally, the last thing we focused on was the ability to actually turn around application development very fast. So we'll do a demo and you'll see how quick it is. And it's actually in under 3 minutes that you can get up and running with Oracle NoSQL Database Cloud Service. And one of the keys for developing is to be able to use something like schemaless JSON very quickly to actually iterate when you maybe don't know exactly what your data is going to look like. Maybe you just want to use JSON because it's an extremely convenient and flexible data format. For data interchange, we allow full schemaless JSON development. We also provide the ability to auto-scale the application so you don't actually have to size it. We'll talk about that in some detail in a minute. And then essentially, you connect to the service, you create a table, and you go. You start writing and reading data. And again, we'll see that when we do the demo. Okay, so what are some of the needs that we actually deliver on rather than the sort of wants that we focus on? Of course, security is just a crucial need. It's table stakes for any production capable cloud service. So we offer encryption at rest and over the wire using AES 256. No issues there. We are fully integrated with cloud identity. So from an authorization perspective, you connect to a well-known URL, you use your cloud authentication credentials as your cloud identity user. From an authorization perspective, because we are integrated directly with cloud identity, you can put fine-grained authorization policies at the NoSQL database table level. And these policies live again in IAM, which is the global identity manager for the Oracle OCI. The predictability side we talked about both at the latency level. So the service offers predictable single-digit millisecond latencies. Typically, that's anywhere from 2 to 6 or 7 milliseconds on the read side, anywhere from 5 to 9 milliseconds on the write side. So we take this very, very seriously. We have measured allocated capacity on our back end, and we scale that out specifically for offering single-digit millisecond latencies at the 95th percentile. So we're very, very focused on that. Also, this notion of you can actually create a table that will just auto-scale, and it will just scale itself as you are doing reads and writes. Or if you actually know something about the sizing of your application or your workload, you can pre-provision the read and write capacity for that table, and you can save a bunch of money. And we'll see that in a second. We'll talk some details about that. The other important piece here in terms of absolute table stakes is the predictable availability piece. So Oracle NoSQL Database, as we will look at the architecture, replicates the data 3 ways, and we have a bunch of smart routing algorithms that are able to route around failed nodes. And then on the flexibility side, you want the ability to basically model your data the way you want to model it. So you may want to use schema with JSON. You may want to use fixed schema. You may just want to use key value APIs, get and put. You can do all of that with the Oracle NoSQL database and the cloud service. Of course, you want flexible, cost-effective pricing models. As we talked about a second ago, you can use auto-scaling, you can use provision throughput. We have a BYOL model. We're going to talk about this in a second, where you can actually run open source on any cloud that you like. But again, use whatever pricing model meets your needs. And use whatever deployment model meets your needs. You can run on OCI, the fully managed service. You can deploy it yourself on OCI instances. You can deploy it on any other cloud provider that you see fit. Okay, so how do we actually do this? What does Oracle NoSQL Database kind of look like on the back end? So from the underlying storage model perspective, we are a shared nothing distributed key value store really under the covers. And as you can see in this diagram, probably the best way to think about this is we auto shard a table into a very large key space. And in every shard in the cloud service, we actually have configured it to use 3 replicas. We automatically elect a leader node in one of those 3 replicas on every shard. And that leader node handles all of the transactional ACID properties for write operations. And then reads can be routed either to a leader or to any of the replicas. But the bottom line with the replicas, and one of the reasons we're able to offer high availability and predictable availability, is that these replicas are striped across fault containment zones. So if any disk device should happen to fail, we have 2 other disk devices in 2 other fault containment zones. If a network connection should happen to fail, we have 2 other fault containment zones. Or if an actual fault containment zone itself happens to fail, in the case of an availability domain, it may be a metro area data center, we have 2 other fault containment zones that can pick up the workload. Now, from the developer experience, what you all will see if you go and interact with the service is that when you bring up the console, it's really just a table service. There are no instances to create, no databases to create, no IaaS instances with cores to spin up. You basically show up, and as you're looking at here, you create a table. You may wish to create that with provisioned capacity, read units and write units, and gigabytes of storage. You may wish to create it as auto-scaling. But the bottom line is that really all you're doing is showing up, creating a table in a cloud identity compartment, connecting to that table, and then writing and reading data. Okay, so what does that look like from the development experience? So again, we talked about the flexibility in data modeling. So here we have three different types of access to the same data. So you can see that we're creating a table with three columns, an ID that's a generated ID by the system, a reservation number that is just a string, and then a value that is a JSON document. And you can see in the first column, we're doing simple key value access. We're just creating a record that is essentially a Python dictionary. We're creating a put request against the table. We're setting the value, and we're just calling the put method. Really, really simple. Very similar access for doing a get. If you wanted to do a get by primary key, you would just set the key in the record, create a get request, and then call handle.get. And we will return you that dictionary. For actual schemaless JSON access, maybe you actually want a little bit of a richer access method where, for example, in this query, we're actually trying to retrieve an attribute fairly deep into a JSON path hierarchy. So we're pathing into the value column of the table, then we're going into the bag info JSON array. And in that bag info, there's a last seen attribute, which is where this bag was last seen. We are projecting that out in the query, and we are also putting a filter on the tag number in that bag info array. So as you see here, we have a very really rich SQL dialect for JSON. You can go as deep as you want into JSON hierarchies. You can dot into that. You can specify filter predicates anywhere in the JSON. You can use and or expressions. But furthermore, more importantly, you can actually create You can actually create indexes on arrays, or even combinations of arrays or nested arrays. We offer an incredibly flexible and rich indexing framework over that JSON. And of course, in this example, we're just creating a query request with that select statement. We're calling handle.query. The result, again, we get back as a dictionary, and we have our result back. What you see on the right here is fixed schema access. And lo and behold, it looks exactly like schemaless JSON access. One of the really, really nice things about Oracle NoSQL is that you can decide to change your schemaless JSON access into fixed schema, because we also offer hierarchical structures, which are records, and records contain arrays and records and so forth. So you can take a schemaless JSON value. If you want to save on storage, for example, on the back end, you can convert it to fixed schema, and all of your queries will just run. Zero code change. Okay, so on the flexibility side, in terms of the pricing models, we're looking at three of the pricing models that we offer that are probably the most interesting. As we talked about earlier, we have this provision throughput model where you, if in fact you know a little bit about your workload, and you can tell us basically how many read units, how many write units, and how many gigabytes of storage you'll need. You pay for that provisioning. And the bottom line here is you will reap a very significant discount if you have done some of the sizing and you know something about your workload. So as you see here, the price for a 1K read unit, which is the ability to read 1K of data per second, is about half a cent. And the ability to write 1K of data is about 12.5 cents. And of course, the price for storage is about 6.5 cents, and these are all monthly numbers, right? So if you if you want to read 1K of data per month, and allocate one read unit, that's basically 1K of data per second, right? So it gives you something like 2.4 million reads for the month. It will cost you half a penny. So really, really cost effective. Of course, it depends on you knowing something about your workload and having the ability to provision that. And of course, you may get throttled if you go above those limits, and you can actually change that via an API if in fact you get a throttling exception. The other alternative, if you don't know anything about your workload other than, hey, I may need, say, a terabyte of storage, is that you can create the table with just the storage limit, and we will automatically scale the reads and writes on the back end as you actually consume them. And the key difference here is that you really only pay for the reads and writes that you consume at runtime. Now, the difference here is that you'll actually pay a bit more for this, but in fact, if you go idle for significant amounts of time, you pay nothing at all. And so this is really good for those cases where you may have very non-deterministic workload, but you want to be able to serve those customers with, a great user experience and great latency, and you just want the system to scale to meet your demand. For that, for Oracle NoSQL, you'll pay 16 cents for a 1K read unit. You'll pay $3.12 for a 1K write unit. Again, it's still a pretty cost-effective option when compared to, for example, DynamoDB. And then finally, we talked about it a minute ago, there's the bring your own license option. You're welcome to run the open source version of NoSQL Database, stand that up in any cloud of your choice. If you need questions answered, you can go to the forum or Stack Overflow and get those questions answered. There really is no enterprise support for that. Alternatively, you can purchase an enterprise license and get some additional features like extra security features and the ability to use our streaming Reactive Streams API, as well as support for multi-region tables. Okay, now the other piece of flexibility here that we wanted to briefly talk about was the ability to do real ACID transactions and really to do these at scale. And so one of the things that you really have to be careful about when you talk about ACID is the ability to deliver on the real benefits of ACID, and all while you're doing that, not really affect the ongoing latency and throughput of the rest of the operations in the system. And so the way that we do that is we offer ACID on a shard local basis. So when we look at ACID, there's of course the atomicity piece, the consistency piece, isolation, and durability. We'll talk about consistency first. On the consistency side of the house, we actually offer two options for consistency. You can actually decide to always do consistent reads, which actually means we will route that read to the leader of the shard, the elected leader of the shard. I'll talk about why that's important in a minute. You can choose to do an eventually consistent read. And in that case, we will route that read to the replica of that shard that has the lowing, trailing, average latency. In terms of cost, a fully consistent read will cost you 2 read units, while an eventually consistent read will cost you 1 read unit. Now, on the writes, if you do a write operation, we will always route those writes to the leader of the shard, and this is how we offer fully consistent reads, right? So really, to offer shard local transactions, you have to be able to basically always guarantee that you can read your writes, and that writes are always sort of increasing in a monotonic fashion in order. And the way this is done by always relying on a leader node that has the most recently committed transaction. And then you may wonder, well, I want to actually do a multi-record transaction. How can I do that? Well, in NoSQL, we again need to carefully balance this notion of ACID, scale, and latency and throughput. And what we've done in the backend on Oracle NoSQL is we've given the application developer the opportunity to create this parent-child relationship and co-locate all of the data between parent entities and child entities on the same shard. So if you look at this create table, we are creating an app config table, and we're giving it a shard key of the ID. And then we are saying, hey, we're going to create this child table called appconfig.config properties. We're going to add a shard key to that called the config property. But in the back end, the child table will actually share the ID in its shard key with its parent table. So whenever you actually supply basically it's a collection of objects of parent and child records to our APIs to do a write, we will actually do that in an ACID fashion, and it will be fully atomic, fully isolated, and durable because it all lives on the same shard. Okay, so on this whole notion of predictable behavior, right? Really, really critical that when you use a system, it offers, some notion of predictability. And what you're looking at here is a measurement that we took, and we constantly are measuring the system and alerting when we go beyond these bounds. But what we're looking at here is our latencies at the 95th percentile. And what that means is that 95% of the requests are within these bounds. And the dashed black line there is our write latencies at the 95th percentile. And what you can see there is that we are consistently under 10 milliseconds. And then the dashed red line are the read latencies at the 95th percentile. Again, consistently under 10 milliseconds at that 95th percentile. And this will scale out no matter how much throughput you are requesting for the system. We will have the ability to deliver on these predictable latencies because, as you've seen on the back-end architecture, we just scale out horizontally in a shared nothing fashion by just adding shards to the system. Of course, not only do you want predictable latencies as measured by the application from the API, but you also want predictable availability. We offer 4 nines and a 5 in terms of availability. This is done via, of course, redundancy on the back end by our 3-way replication. It's also done by the ability of the back-end system to actually detect and route around failed nodes, the ability to actually detect a failed leader node and dynamically hold an election at runtime to elect a new leader node. And finally, this notion of striping these replicas across fault domains really allows us to deliver on 99.995 availability. Okay, so again, a little bit more about how we actually designed this service to offer predictable latencies, right? It's all good to just say we do it. We'll give you a little bit of insight into actually how we do it on the back end. Of course, the shared nothing horizontal scale out is great. It gives us the ability to expand elastically while the system's up and running. We will rebalance the cluster. We also have this notion of being able to route eventually consistent reads to any replica that has a low and trailing average latency. The other key piece here is this reservation-based throughput on the back end of the system that we use. So, of course, when a table is created, there's a reservation on the back end that happens, and we will actually look for a cluster that has enough headroom, enough throughput that has been measured that we can deliver the throughput that's been requested at the latency, at the single-digit millisecond latency at the 95th percentile. So we actually have measured the system on the back end in terms of capacity management. We've carefully characterized these systems so that we know per node in the cluster how many read and write units we can deliver while maintaining single-digit millisecond latencies. So in no uncertain terms, we know actually the capacity of every one of these systems. So we know we can deliver on these 95th, these single-digit millisecond latencies at the 95th. And then the other key piece here is we will actually throttle applications that are trying to go above their reserve limits. So we actually rate limit. As well as for expensive table scan operations, we actually limit those on the back end in terms of how much capacity each iteration of, say, a table scan can use on the back end, so that we actually are fair in our scheduling on the back end, and we don't take up too much capacity for other ongoing operations for other tenants that actually need that capacity. And then from an operations perspective, we will actually have our own internal alarms that fire when we're getting close to 65% of sold capacity, or at 65% of sold capacity. And then we will actually expand those back-end systems when we get to 75% of sold capacity. Okay, so we are now going to do a demo, and we're going to show you actually how to get started with Oracle NoSQL, and we're going to do it in under 3 minutes. Okay, so as you can see, I've logged into the Oracle OCI console using my browser, and so we'll just go to the database section, and under there you can see that Oracle NoSQL database is there as a table service, as we discussed in the presentation. So I'll go there, and I will actually pick a compartment, and I've got one here called developers.dave, and I will go to that compartment, and you can see I've got a table there. Let me just create a new one, and I will give it a read capacity of 10, a write capacity of 10, and I will give it a gigabyte of storage. I will call it my table 1. My table 1. I will give it an integer column called foo, and I will set that as the shard key. I will give it a JSON column of, I will give it a column name bar of type JSON, and I will go ahead and create that table. So as you can see, the table is now in the creating state. It takes about a second to actually work its way through the cluster on the back end. I will just go ahead and insert a row of data, one for the primary key and a little hello world JSON document as a string. I will go and look at the data just to see if it made it into my table, and there's my data. So NoSQL database in about a minute to get started. Thanks so much. Okay, so we've done the demo. We've explained why we think Oracle NoSQL is the most flexible NoSQL database on the market today. So what's next? Try it yourself. See if you like it. We think you'll actually love the development experience. You'll love the predictability. We have an always free tier currently live in the Phoenix region of OCI. We have a hands-on workshop here. Please attend that. We'll show you actually how we developed an application on the store, and you'll get hands-on on the actual cloud service. And then continue the conversation with us. You can find our information at www.oracle.com/database/NoSQL Cloud. And hopefully you'll agree with us that we are indeed the most flexible NoSQL database on the market today. Thank you very much.